Hello, my name is Stan Crisp, and today I would like to take the mystery or magic out of how a heat pump works. A heat pump is an assembly of components that is used to move heat energy from one point to another. In this demonstration we have four components. A fifth component is many times used, and I'll describe that at the end. In this case we have two heat exchangers, one known as the evaporator heat exchanger, and it's a coil of tubing inside this container of water. And we have the other heat exchanger known as the condensing heat exchanger. It's also a coil of tubing inside a container of water. We have a compressor that squeezes your refrigerant gas, and we have a pressure reducing device, which in this case is this capillary tube. Now the way this works is the refrigerant gas at this point comes into the compressor and squeeze. And a basic theory of physics is when you squeeze a gas, when you compress a gas, it will become hot. So you come out of this line much hotter than you came into the compressor, and you can see monitored by this thermometer right here, we're at 119 degrees at this point. The refrigerant flows into the copper tube, releasing its heat, and it has raised this body of water up to almost 97 degrees. It cools the refrigerant. You can see coming out at this point it's 114. It also changes that refrigerant to a liquid, and that gives up quite a bit more heat as well. The refrigerant flows down this line, and through the capillary it does the opposite of what the compressor is. It relieves that pressure, and you can see by relieving the pressure the temperature has dropped significantly. The thermometer says we're down to about 44 degrees, and you can even see frost accumulating on this tubing. The refrigerant goes through the coil of tubing in the evaporative heat exchanger, and it is absorbing heat out of the water, making that colder. We in fact have ice forming down there on the tubes, and then the refrigerant comes back out through this line, and it has been warmed to 58 degrees, and it is now ready to be compressed again and repeat the cycle. Now the missing component here is the reversing valve, which simply allows you to go in the other direction without doing anything more than the flip of a switch. In this case, we're removing heat from this container of water, and we're putting it in this container. By flipping a reversing valve, it will reroute the flows, and then you'll start removing heat from this container, and you'll reject it into this body of water in this container. Now the reason for doing all of this is tremendous energy savings. By this chart you can see that to transfer the energy using a heat pump to move 1,000,000 BTUs, you might spend on the order of anywhere from $6 to $8.50 based on your electric rate, $8.50 to move it with a geothermal heat pump. An air source heat pump would, under ideal conditions, would be a little bit more. But if you were to burn natural gas, run electric resistance heat, or to burn propane, it's going to be significantly more for the same amount of energy, simply because it is more efficient to move energy than it is to burn a fuel to create the heat. So if you have any questions or would like to comment about what I've done here, please feel free to get in touch with me. My email address is stanc@aquacal.com.